What's up, y'all? We're going to evaluate the integral of e to the negative tx cos x from 0 to infinity, and we're going to do that using the most popular method, which is by integration by parts. Now, this isn't my favorite way to do this. There's a much easier, cleaner, faster way to do it, but watch this, see what you think, and then go through what I think is the easier way, and you can decide which version that you prefer. Now, t can be any real number that we like. So to do this, we're going to set u equal to e to the negative tx, and then dv equal to cosx dx. Then we'll take the derivative so that du equals negative t e to the negative tx, and then integrate dv to get v equal to sine of x. Now we'll take these and plug them into our integration by parts formula to give us u times v from 0 to infinity minus the integral of v du. And this negative cancels out with this minus sign to give us a positive sign right here. Now we'll evaluate this term, and in the limit as x goes to infinity, this goes to 0 because of the exponent is negative, and this term goes to 0 as well because sine of 0 is 0. So this whole thing is 0. So what the integral becomes is t times e to the negative tx sine x. Now it looks like we made things worse, right? Like we gone from here to here, we added a t, we switched a cos to a sine, which isn't a big deal, but it doesn't look like things got better. But this is the trick. This is the sneaky part. We're going to do integration by parts again, a second time. Yes. So we'll set u equal to t times e to the negative tx. Then dv will equal everything else, the sine x down here. Take the derivative, du equals to negative t squared e to the negative tx. Take the integral of dv to get negative cos x. And we'll take these right here and plug them into our integration by parts formula to give us u times v, which is what we got from here, 0 to infinity, minus the integral of v, which is cosx du, which is this part right here, and these negatives cancel out, so we're left with this. Now to evaluate this term, it's not too bad. In the limit as x goes to infinity, this term goes to 0, right, because of the negative. Cos of 0 is 1, so this whole thing becomes positive 1 because these two negatives cancel. Now, what we'll do is we'll take this equation and we'll sub back what I of t is. So I of t is this right here. We sub that into there. Here's our 1, which is the number that we get from evaluating this integral. And I just pulled out the t squared out of the integral. I can do that because we're integrating with respect to x, not t. T is a constant, so we'll just pull it out just like that. And if you look at this, the integral that was presented to us from integration by parts a second time right here is exactly the same as the integral that we're trying to evaluate. So we can solve for it by literally combining it over. So we'll take this t squared and add it to here, which is like a 1, kind of factor out. We have 1 on the right hand side, and then to solve for our integral, we'll divide both sides by t squared plus 1 to give us the integral of e to the negative tx cos x in all its glory. There we are, y'all. So this is a lot of work, integration by parts twice. I strongly recommend checking out this easier, faster way that I prefer doing it. It'll give you another tool in your integral tool belt. That's always a good thing. And lastly, hang in there. I know integrals are not easy to learn, but the more you do, the better you'll get. You can survive. I'm with you every step of the way. Cheers.